Hello, everybody. We're ME51 and we're working on retrofitting an ultrasonic wire splicer for Sonics and Materials.
I'm Justin to you.
I'm Andrew Frosty.
And I'm Ermin Bahramovich, and we like to give a thanks to our advisor, Professor Jason Lee, and another thanks to our industry sponsor from Sonics, Jeff Meyer. So, a little bit of background on Sonics and Materials. They were founded in 1969 in Newtown, Connecticut, and they specialize in designing and manufacturing ultrasonic welding and ultrasonic liquid processing material. Sonics and Materials, they make 20 kilohertz ultrasonic wire splicer. And what this machine does, it creates an electrical and mechanical connection between lump sums of wire by ultrasonically welding. And our project's objectives are to simplify the gather tool to improve its cost, manufacturability, and repeatability. So the requirements for this project include manufacturing and validating a working gather tool prototype to use this data to create a final gather tool recommendation. Additionally, we will provide possible anvil tool jamming issue solutions.
There are two critical weld mechanisms for the wire splicer, the gather and anvil tool. The gather tool sets the width of the weld, and our goals are to reduce the machining and assembly costs, develop a working prototype, and integrate that prototype into the splicer for testing. The anvil tool applies a downward force on the wire, and we're hoping to fix the jamming issues that cause due to wire debris getting in the gaps in the tool, as well as generate design recommendations and models for these solutions. The gather tool is required to move the gather block, outlined here, up to 10 millimeters, remain stationary during the welds, and produce high-strength welds. The original gather tool to the left is very complicated with a manufacturing cost of over $3,700. Our simple design to the right just uses a linear actuator and a spring return mechanism, which was 30% cheaper to manufacture.
The first test that we performed to validate our design was tensile testing. Using 12, 17, and 20 gauge wires, we pulled at 25 millimeters a minute until failure. From this testing, what we found out was that the wires itself would fail before the welded area. So going forward, we set out to have our design be able to produce welds stronger than the wires themselves, rather than having a set strength metric that we wanted to pursue. The other form of testing that we did was precision testing to make sure that the gather tool design that we came up with was going to be precise. To do this, we extended and retracted the new design by 2 millimeters a second and measured the distance traveled by the linear actuator software and the calipers. The largest deviation that we had was plus or minus 7 millimeters with a caliper accuracy of plus or minus 0.2 millimeters. What we found from this test was that the software defaults to inches, leading to conversion error, but although our test showed that we weren't as precise as we liked, we did find out that we had the accuracy that we want, so with some fine-tuning we could get the results that are needed to have a successful design. Here you can see a video of the integration testing where we took our new design and hooked it up to the existing wire splicer. From this testing, we were able to conclude that our spring return mechanism shown in the previous slides is not actually needed due to the fact that the springs didn't provide any noticeable difference in the retraction speed of the gather tool. By doing this, we're going to be able to reduce the amount of parts in the final assembly. This will in turn reduce the total cost of manufacturing.
The anvil tool is required to apply up to 85 psi to the wires to support friction welding. The problem is that during this process, wire debris breaks off and gets caught in the mechanism. Our potential solutions are to increase the area of the pneumatic cylinder that powers the anvil tool by 51%, install a stiff rubber piece to scrape off the wire debris, located where it says so in the figure, and reroute the nearby pneumatic lines to blow off the debris. All of these solutions have models generated and have been submitted to Sonics for their consideration. The gather tool prototype has been assembled and integrated as well as had preliminary testing done. We've created improvements based on this data as well as generated anvil tool recommendations. Our next steps moving forward are to perform welds with the new gather tool, perform tensile tests on the new welds to verify strength, and further pursue the anvil tool design recommendations. That's where we are currently in this project, which we are very proud of. Thank you for your consideration.